Good afternoon, everybody. Thank you for spending some time with us this afternoon. My name is Dave Jevans, and I'm the CEO of CipherTrace. We are one of the leading companies in blockchain intelligence. We basically use AI and machine learning to analyze millions of transactions per day. So I'm going to talk to you quite a bit about kind of a different use case than what we've heard about in the last few sessions. I thought it was quite interesting the last sessions, because a lot of the technology that was described is exactly how we are building large-scale blockchain intelligence at CipherTrace. So it's great to see that we're all on the same path here as far as handling massive amounts of data, massive amounts of user information. Now, I first got into blockchain in 2011 when Bitcoin really got started. I got very interested in it. I'd been involved in cryptocurrencies for about 10 years before that. So worked with DigiCash, I knew the e-gold people, so a lot of things going on in smart contracts. So I've been involved in the space for quite some time. But things have really, as you know, grown quite a bit in the blockchain world. So what we're trying to do at CipherTrace is to provide a global intelligence platform for all blockchains. Particularly today, they're mostly cryptocurrencies, but as you can imagine, there's many other uses for blockchains. Trade finance is a good example. Supply chain management, supply chain integrity, even electronic voting and electronic identity. So there's quite a lot of use cases for blockchain, but the biggest one today is cryptocurrency. And it's becoming a big, big issue. So for example, we've heard the Chinese government last week come out and say they want to be a blockchain-focused country, and they're putting blockchain education out for everybody in the universities, in the high schools. They want to be the leader in blockchain. And in fact, if you look at cryptocurrency, most of the mining, which is the verification of blockchains, actually happens in China, even though it's a global set of currencies. We've heard our president from the United States, Mr. Trump, speak about blockchains and cryptocurrencies, and they're a little bit scared, but they're also moving forward quite quickly with regulations and best practices. And those of you who have been following Facebook's efforts to build a cryptocurrency will have heard of Libra, where they're trying to bring crypto to over 1 billion people to help people who don't have bank accounts, or to help people move money around the world in a safe, secure way, or to buy products from companies like Rakuten or others. So how do you build this intelligence? Well, it's very similar to what we've heard here, but it's kind of different because we have a very different set of challenges. The data is similarly large, maybe even bigger. But we have some issues around how to manage these massive amounts of transactions and how to understand who is doing what. Because blockchains and cryptocurrencies, by their very nature, are largely anonymous. So we don't tie people's names to their accounts. So one of the key challenges is to understand who is who, where are they in the world, where is their currency, how many addresses do they control, and look for fraud patterns, look for theft patterns, and basically risk rate transactions. So that's what we're trying to do here. So what we did at CipherTrace is packaged all this intelligence into a number of different services that are available to customers like Rakuten, who's one of our customers. There's a couple of different ones. If you have this, imagine this global brain, this huge set of servers, and all this data that is tracking all of these transactions, you need to provide it in easy-to-use ways. So one of the core use cases is what we call anti-money laundering. So this is basically knowing where the bad guys are. So who is moving money around the world that shouldn't be doing it, that is doing it illegally? Maybe it's stolen, Maybe someone hacked into someone's account or phished their account and stole their money. Maybe they hacked into a company and stole their private keys and moved everything off the blockchain. So that's the first one. The second one is investigations. So let's say something bad does happen. How do we build a really easy to use, cool user interface that leverages the intelligence we built from our AI to allow people to trace the money backwards and forwards? Where did it go? Where did it come from? And can we get it back? Can we freeze it? Can we recover it? Now, as blockchain becomes more and more of a global phenomenon and is accepted by more retailers and is an investment product that many, many people want, governments are looking for supervision. So they're saying, I want to monitor the activities of companies in my country to make sure people are doing a good job, criminals aren't abusing them, they're not getting hacked, etc. In fact, we had a meeting yesterday where we had 22 of the top cryptocurrency and blockchain companies in Japan present, and then we met with the Financial Services Administration of Japan later in the day. So this is one of the areas, and I'll show you how this works. Another thing you want to do is be able to understand where problems might be that you haven't seen. So if you think about your credit card, if someone copies it and starts using it on the internet, you want to know quickly, and you want your bank to know and stop it and call you or text you and say, hey, was this you, and prevent the fraud. The same thing is true for blockchain. You want to be able to know beforehand or as it's happening, is there some fraud, is there some risk? And then the last thing is what we call market intelligence. So if you think about cryptocurrencies, for example, other blockchain assets, you really want to know in almost real time what's actually happening so you can make important decisions. So real-time access is very important. And when you're talking about a system that's processing a couple of million transactions a day and is dealing with billions of addresses, the problem to do this in real time becomes extremely hard. Doing it at scale is a real problem. Just a question, has anyone in here ever bought any cryptocurrency? Any Bitcoin, any Ethereum, anything? Yep, bunch of hands. Great, me too. So the customers in this space are really broad. So we have to service many different markets. So with Rakuten, we're working on the wallet side of things to look at cryptocurrencies. We work with credit card companies. We work with banks. We're working with major companies like Microsoft on fraud detection. We work with government agencies all around the world. And we also have to have a lot of partners because you can't just do this yourself. You're bringing data in from all different places. So data comes into the platform, not just blockchain data, but data that might be open source intelligence. So scraping different websites, scraping dark markets, finding out where bad guys are. You've got a lot of intel coming in, and being able to bring that all together into an AI and machine learning platform is a real challenge. So there's over 1,600 cryptocurrencies today that use blockchain. So all of us have probably heard about Bitcoin, some of us about Ethereum. In Japan, almost every bank is starting to work with something called XRP, or you may know it as Ripple. And there's many others. Think about the volume of data here. So if you look at Bitcoin and you look at Ethereum, right there you've got a couple million transactions a day. And then look at all the other ones. If you go through 1,600 of them, it's a massive data problem. And trying to do it in real time is a big deal. The other thing you have to think about in this problem, as we saw in the last three presentations, is not only your data pipeline, but how you do analysis on it. because you're bringing data in, you want to make decisions in real time, but you also have to have a separate data science group that can run models, that can try out machine learning algorithms, and trying to do that to spin up these instances up and down and keep the data sources running is extremely difficult to manage and requires a lot of computation, a lot of storage. So we have all these challenges, and then of course you've got to do it over all of these blockchains. So today we're tracking over 700 currencies, and we have to keep adding more because it keeps growing. People invent new blockchains with different types of data, with different transaction models. So consider this. Ethereum is a blockchain where it's like a bank account. You have an address, and every time you send somebody something, it comes from your address. Pretty simple. You have 100 million users, you got 100 million addresses. Okay, we can understand and manage that. You know, it's like having 100 million customers. But consider Bitcoin, which is a different type of blockchain. Every time you make a payment, it creates a new address. So the number of addresses go up and up and up and up and up. So now on Bitcoin, we're managing more than 500 million addresses. So think about those as users, almost. So now you're trying to manage close to 1 billion users in real time. So it's quite a big problem. And remember, there's this anonymity problem. So let's talk a little bit about how it works. The blockchains are public information mostly. I mean, there are private ones, but if you think about Bitcoin or Ethereum or any of these things, these are publicly available data sources. So we can ingest that data, we can put it into our machine learning algorithms. But it doesn't mean anything yet, because it's just numbers. We don't know who it is, we don't know what it was, we don't know what country it's from. That's the challenge. So you have to build an intelligence network that you can't just get from people interacting with your website. So you've got to run web scrapers. You've got to run systems that connect into marketplaces. You've got to run the equivalent of security honeypots. So if anyone's in the security business here, you'll know about honeypots. Here's an example. If I want to fight spam, what I do is I create 50 million email addresses that don't belong to anyone. And if I ever receive email at those email addresses, I know it's spam. And then I can start blacking it out. That's how it works in the spam world. That's one of the main techniques. Similarly, it's true in the blockchain world. You can create addresses and see if people send money to it or do transactions with it, but you can also create honeypots that monitor transaction flow. Then you get data from users. So sometimes you get users who will tell you, oh, this is an account in Vietnam. Oh, this is one in Singapore. This is one in California. Or maybe they say, oh, this money was stolen, or this was fraud. So you've got to get all of that. Then you take it and put it into the machine learning algorithms. So you've got all of this big data, all of these transactions. If you think about blockchain, it's not just a linear list. Some people think of it at just every 10 minutes there's a block. What's inside of it is a very complex graph. You're talking about one of the most complex graphs in the world here. And when you combine them together, so take Bitcoin, Ethereum, all the other currencies, you've got multiple intersecting graphs that have rough connections between them, and you have to establish those connections. So it requires a number of different approaches. And I can assure you that we have failed on algorithm development more times than we have succeeded. And that's the benefit of having data scientists, isn't it? It is science. Not every experiment succeeds. You have to try different algorithms, different approaches, and every time you're trying something, performance requirements go up and up and up. So we're talking about different types of clustering algorithms, different types of analysis, Bayesian clustering and analysis, various kinds of learning algorithms, different association type of algorithms, all have to be tried. And as you get more data, it turns out the algorithms, you have to develop new ones, because the data sources are changing all the time too. This is a very evolving space, and people are inventing new things all the time, so the algorithms you have to invent are actually different all the time. It's not just, for example, I want to track what you bought and then propose you new things. You know, you bought white sneakers, I'll show you 5 white sneakers. That's an important problem, but we're talking about things like there's sneakers, and then there's airplanes, and then there's money systems, and then there's cars, and then there's camels, and then there's voting systems. I mean, imagine like the diversity of all these things people are inventing for blockchain. So when you have it, then you have to classify it. So you want to go through and analyze clusters of transactions and try to figure out which addresses belong to one person, or one business, one entity. I'll show you what this looks like. You'll see some pictures in a minute that will make it clear in your mind. And then you want to go through it and say, okay, well, these are all good, these are all risky, these are all bad. So how do you figure out what's good and what's bad and tag it into the blockchain to create the data, so that then you can deliver it both through an API and a user interface. So, how do you get a training data set for all this? Because anyone can analyze a blockchain and come up with transaction graphs, but it doesn't mean anything. You have to have worldwide coverage of the blockchain users. There are probably 550 cryptocurrency exchanges in the world that are active at any one time. So these are companies that use blockchain to move money around. You can go to famous exchanges like Bitflyer or Coinbase or these types of things, but there's hundreds and hundreds and hundreds of them. You need to be able to get access to them. You need to perform transactions to and from them. And this starts to give you base tagging data, which you can then put into your algorithms to say, oh, well, if I know this one address belongs to this one company, then these million other addresses belong to it as well. So the global coverage is a big challenge, because you're not only trying to do who are all the good guys, you're also trying to find out who are all the bad guys, and then integrate that data in as well, so that your analysts and your transaction processing systems can use it. So think about, it's not just a data processing problem, it's also an intelligence gathering problem, and then being able to tag it into your blockchains and then run it through your analysis algorithms. And those are all the good guys. There's some very challenging data sets to gather as well. This is an example of an Iranian exchange. So most countries have some form of sanctions against this country, and you'll have to report transactions to and from it, or you may not even be allowed to do it. So getting tagging data on things like this is extremely difficult. It's really easy to get tagging data on the good guys, but on the bad guys, it's extremely challenging. And they go to lengths to make sure you can't do it. Has anyone ever seen a Bitcoin ATM? A few people, I see a few nods. You know what an ATM is, you go there, you put your card in, you get money out. Well, there's a whole world of these Bitcoin ATMs out there, and it's growing very quickly. And these allow you to get onto the blockchain, put money into the machine and buy crypto, or go to the machine and pull cash out. And you can pull out quite large sums out of these things. So you have to map these as well. You need to map the blockchain addresses that belong to these cryptocurrency ATM companies and map that into your data set. And it's a global problem because they're all over the world and growing fast. Many of you have probably heard of ransomware. This is like your traditional viruses or malware, but it encrypts your computer and then demands ransom payments. usually using blockchain-based currencies. So how do you get tags on where the ransomware guys are? Well, I'll show you how you do it in a minute here. But that's important because what you can do is you can start to find out who the bad guys are and then track them so that if one of them comes to your site and tries to do a transaction, you can block it. You also have to track money laundering services. So these are services called mixers, or sometimes they're called foggers or tumblers. These are services where you send money in, it mixes it with other people's money, and then sends it back out to you. So it's designed to try to hide any kind of tracking. So you have to identify these as well, and then run transactions through them to get base level data to train your model. And here's an example of what a trained model looks like. So what you're seeing here in the pointy things are transactions, the round elements are addresses. So on the right-hand side, there's a little blue circle. That's putting money into a money laundering service. We can see it goes into a transaction. All of the yellow ones are other people's money. And then it pays one person out. It moves to the next one. You can see a second circle. That's all other people's money. It pays one person out and then moves forward again. So once you start being able to identify these transactional patterns, your machine learning takes over. And you can now go analyze 2 billion transactions and find examples that look like this and start to cluster them together and say, anytime I see a pattern like that, it almost for sure belongs to that money laundering service. Does that make sense? I hope so. Okay. You also need to find other bad guys. These are Syrian Mujahideen terrorists advertising on Facebook. And you can see here they put their Bitcoin donation address at the bottom of their banner. Okay, you need to track these guys. You want to figure out who's sending the money and also where are they getting the money out. And again, back to when you start identifying them and tracing them, you can use that as core-based training data for the model to go find more of them. Here's what it looks like. So in red, that red circle, that's them, that's their address that was on the screen there where they were asking for the donation. That's that red circle. You can go backwards and see where the money came from, and here we can see money came from somebody with a US account in blue. Now what's interesting is the model can go forward as money moves through the system, through the blockchains, and we can actually see on the right-hand side there in a circle in green, there were 17 other people donating. So the model can start to find other people who are involved in these same activities, and then we can see where they were cashing out, where they were turning that into yen, euros, or dollars. Now what's interesting about this is once you start to identify sites, you can then start to analyze them as well. Because the blockchains are public, if you can identify one of these entities, you put your model on it and it will go and identify all of their transactions over time, and you can start to see what type of transaction activity they're doing. There's a thing called a dark market. So we all use, mostly pretty good markets on the internet. We use Rakuten and other things. But there are markets that exist in the dark web that you can only access through a Tor browser, so you can't find out their IP address. And these are typically used to buy and sell illicit goods. It's usually drugs, sometimes it's weapons, other times it's stolen credit cards, stolen bank account information. But once you can find out where these are and start to train your model, you can now figure out where's the buying and selling going on. So in this case, we're tracking something called Hydra Market. And you can see, we're now able to see on the left-hand side, the green is money coming in. So these are where people are buying things. Where's the money coming from? And the orange is where's the money coming out? And you can see through this example, 80% of the money coming in is coming in from one service, and 80-something% of the money going out is going through another one. So you can now start to see these are risky services that I may not want to be doing business with, all through blockchain analytics, powered by machine learning. Here's a very concrete example. On the left is another set of dark markets. This is Agora and Evolution. So we got involved with this. Here's how it started. A gentleman in Canada was trying to buy weapons, trying to buy handguns, a Glock, with a silencer on one of these dark markets. And it turns out he was dealing with a Homeland Security agent who had taken over the account of the weapons dealer and was manning it. Of course, they didn't know that, but so he talks to this weapons dealer, says, I want to buy this weapon. He pays with cryptocurrency. So they ship him a fake weapon, but of course they know his address now. So he was buying it from Australia. They ship him a fake weapon. Oh, interestingly, the guys who were shipping the weapons were putting them in blocks of candy, like fudge, chocolate fudge, and they would ship them around the world and it would avoid any kind of detection. So it's an interesting thing. So the police show up at his house, wait for him when the package comes. Go into his house, arrest him, hey, you're buying weapons. And then they find all kinds of drugs. He's got 2 storage lockers full of it, and Federal Express packages to send it to people. Strangely, he didn't have any cash because he was using blockchain technology, crypto, to basically manage all of his cash in his businesses. So we were able then to trace backwards using the trained model to figure out, oh, all of his money was coming from these different marketplaces. And he had about $7 or $8 million in his account. And we were able to find it, have him prosecuted, and get him thrown in jail for 8 years. So here's a practical example of how this stuff works. Okay, we talked about ransomware. How do you get a sample of ransomware? How do you actually train a model on ransomware? Because usually the way ransomware works is someone gets an email and it encrypts their computer and then they pay, or they do, if they're smart, they have a backup and recover their data, but not everyone does, or their backups don't work. So what we do is we get a sample of it, we fire up a virtual machine, run in Windows, and we infect ourselves on purpose. So we get infected. So our computer's now infected, we get this message that comes up that says, hey, you gotta pay us this ransom at this address, and then we'll decrypt your computer. So we pay it. So this is us on the left-hand side paying the ransom. The blue is us paying the ransom. The first red circle, that's the bad guys. But you can see here there's 6 other victims. We've already been able to identify 6 other people through this machine learning that were also victims. And as we move forward through transactions, we can now see 82 other intermediate addresses. So now we're starting to map out the network, and we can now see where they were cashing it out. They were cashing it out at a company called BTCE, which was in Cyprus, feeding Russian money launderers. So through the machine learning, we now can train the model. Now let's get more data into it. We get a bunch more data into the model, and here's what we discover. We run this thing. It actually took about 2.5 weeks to run. We had to analyze a couple 100 million transaction chains deep in through the network. So this took about 2.5 weeks to run. And what we can start to see is a cluster. And then we apply the tagging to it. And what we got was a map that showed where all of the world's ransomware payments were going. And we can see here in the center, it's all going to one place. I mean, there are outliers around it. There's a little bit of outliers everywhere, but probably 97% of all ransomware was being actually operated by one group going through one exchange. So this allows us not only to find the bad guys, but also to prevent people from either getting infected or from accepting money from these bad guys. And we provide it not only in that user interface you saw, but as a set of APIs, of programming interfaces, where now you can start to risk score when money comes in or money goes out on the blockchain. Of course, you have to do it in real time. You want to do it in milliseconds. So imagine this thing has to run pretty quickly, and you're constantly training the model because there's new data coming in every 10 minutes, so you're running training runs every day or so, but you're updating the core data at minimum every 10 minutes, and sometimes as much as a couple times a minute. We're trying to get to full real time. That's a hard problem when this data is streaming in so quickly, because you've got to manage the whole graph. And the graph has billions and billions of nodes and edges. But if you can provide a risk score, you can come back and say, risk of 1, this person is really good, never done anything bad, you should accept it. Or risk of 10 out of 10. This was a ransomware person that was receiving ransomware, they're a bad guy. Freeze their account. So this is one of the core use cases of it. This is very practically how this machine learning and AI actually improves the safety of everyone using this stuff, improves the safety of merchants around the world, banks, and cryptocurrency investors. So last couple of items I'll show you here. This is large-scale training. So this is the result of a trained model that is now looking at who are the guys who possess massive amounts of crypto. Where's it coming from? These circles here are clusters of addresses that the model has discovered are involved with transactions over $1 billion. So when someone moves $1 billion on a blockchain, we get kind of interested. So we want to figure out where's that money coming from. Is it legitimate? Is it not? Is it a nation state moving money that they stole? Is someone mining stuff? Where's it coming from? And through the model, we're able to start seeing these clusters, and each one of these are between $1 million and $120 million per transaction that are coming together to basically feed a $1 billion transaction. And we're able to identify most of it coming out of China, and we're also able to identify the mining pools where they're generating these cryptocurrencies from. So it's pretty interesting because now you can start saying, well, actually, we're worried that maybe that was one of the sanctioned states and it was stolen money, but we can actually see in this case it's legitimate. It's just someone who's got a lot of money. You can also start seeing how these networks work, because now you can say, oh, well, these are all controlled by the same business, the same entity, and understand the inner workings of how their transaction flows work. We use this information to generate reports, so it's not just the software, it's also reports that are used around the world by companies, banks, credit card processors, and governments. And we're able to use it to start informing governments on how they should regulate this stuff. Because I think blockchain is here to stay, it's going to be huge, it already is huge. But there has to be some controls around it. So hence our meetings with folks like the Japanese Financial Service Administration, or FinCEN in the United States, or Malta and their financial administration. So we map it out, we're able to start showing in the world, based on all of this data and the results of our AI, what kind of regulation you need to do, what are the risks. And then it's working, because we're now able to start see regulations being passed and schedules for it around the world that will help grow the blockchain industry, but keep it safe. Keep scammers out, keep criminals out, and create a viable global system where anyone can move money anywhere safely. Here's an example of it working in real time. So on the left is an exchange that is using this technology. And you can see here most of their transactions are green. We're mapping transactions out over about an 8-month period. You can see it's working. Almost all their stuff is green. There's a little bit of bad stuff, but it's mostly green. Just like with credit cards, there's always some stolen credit cards in the world. Here's one on the right. Same time period. And you can see that they're not using this technology. They have no AI, they have no ML, they don't have any anti-money laundering controls on their blockchains. And look at it, 50% of it's bad. Red is stolen, orange is dark markets, and yellow is money laundering services. So 50% of their transactions are bad, and that's the fastest growing part of their business. So you can see right here, this stuff actually works. So I'll wrap up with what blockchain intelligence is useful for. So financial and threat intel. The anti-money laundering that we just saw, so keep bad guys off your blockchain. Investigate it when something happens. And regulatory and audit. I'll leave you with one other thought about where this is going. Because this stuff is often used for money, blockchains could be used for many things, but oftentimes currency is the biggest use case. And these markets move up and down. If you have very good intelligence, you now have a predictive ability. So not only can you predict the bad guys, but you can predict how markets are going to move. And this is a very valuable thing for investors and for the banking industry, the stock industry, the hedge fund industry. So this kind of intel is really, really valuable for creating money as well as for protecting everyone. And I have about 2 minutes for questions if anyone would like to ask any questions. No questions, really? Come on. All right, well, I'll be around for a little bit, a couple hours today, so I hope to see you later at the event, and you can ask me in person. Thank you very much.